This video will show the demo that how can we run a 2D frame analysis. This is the command to run the 2D frame analysis for dead plates and continuous beam. Okay, so this is the page. So before giving any data, first you fix the scale factor as required. Okay, then this are the text box where you can give the coordinates of a particular member, and this is how, by clicking this command, you will draw a member on the screen. This can be used when you want to draw a frame where the story heights are different. Okay, but when the story height are the same, and no matter that the width of the base are different, you can use this command. So let us use this command to draw the frame. Write the number of base in frame is say 4. Okay, whatever value you give in the text box has to be saved by pressing the enter key or by clicking the OK button. Okay, so let us press enter key. Okay, now write the number of stories in the frame. Number of stories is equal to 0 if the frame has only one floor, that is, if there is only ground floor. Write the number of stories equal to 0, but we have ground floor plus first floor, so let us write 1. Press enter. Let the typical height of the story 4 meters. You can press enter or OK, click OK. Right. Write the width of the bay 1 4 meters. Width of bay 2 4 meters, width of bay 3 4 meters, enter. Width of bay 4 4 meters, please press enter. Okay, so this is how the frame is drawn. Now this is asking, are there any further members to be drawn? If you want to draw any members further, you can draw by giving the coordinates of individual member and pressing this command. But we don't want to draw any further members, so we will click no. Click finish. Okay, finish. This page shows that how the text box are to be numbered. These are frame joints, these are support joints. The frame joints are to be numbered first and the support joints are to be numbered last. Okay, so is the drawing complete? No. Now let us give or number the text box. Just click on the particular text box and the number will be populated. 1 2 3 4 5 6 7 8 9 10. Okay, so these are frame joints, these are support joints. 11 12 13 14 15. Finish. Exit. Is the drawing complete? Yes. Have you filled the text box? Yes. Okay, now write the total number of frame joints excluding support joints. So these are the frame joints, 10. Okay, press enter. Okay, write the number of support joints, that is 1 2 3 4 5. Okay, 5. Press enter or click OK. Right, now support number 11 is fixed, 12 is fixed, 13 is fixed, 14 is fixed, 15 is fixed. Okay, now we can see that all this text has turned to blue because we have assigned it as a fixed support. If we had assigned it as a hinge support, then it would have turned to green and red for roller. Okay, now select the load option on the top right. Okay, if it is the folded plate, select manual command. If it is a continuous beam, use manual command. Or if it is a frame with having member less than 3, then also you have to use manual command. Otherwise you can use this command. Okay, so let us give the data to the member. First, width to all the members. Say the width of all the members is 250 mm, that's 0.25 meters. Press enter. Okay, so you can select this command and drag the mouse and select all the members together. Okay, so when the member turns to blue means it is selected. Assign the value. Now let us select the value of depth. Say all the beams are of 450 mm, that is 0.45 meters. Press enter key and select the beams individually, or you can select together. Okay, assign the values. Now let us assign the depth for the columns. Say all the columns are 600 mm, that is 0.6 meter. Press enter key. Okay, and you can select the member. Now you can see when I bring the pointer near the member, you can see the member number, and one of the text box turns to yellow and another remains white. This yellow text box refers to the initial point of this member, and this joint is the terminal point of this member. Now click on the member and select the member. Okay. Okay, you can also use this command to select the members together. Assign the value. Okay. Now let us give the load. Say there is a UDL of 75 kN per meter on some members. So press enter key. Select the members. Say this member, this member, this member, and this member. You can see the loads. Okay. Okay. Now assign the values. Okay. So in this program you can give a triangular load, 5-point loads and 2 axial loads and 2 VDLs, okay, and moment at initial point and terminal point. But while giving the point loads, we have to remember that P1 is the first load from the initial point, P2 is the second load from the initial point, that is the distance of P1 from the initial point will be less than the distance of the point load 2 from the initial point. So let us see how to apply. See, the magnitude of point load P1 is 50. Press enter. Write the distance of the point load from the initial point. Say it is 1 meter. Press enter. This is the member where we want to apply that point load. So this is your initial point. So the distance 1 meter given is from this point, right? So let us click this member and we can see the point load. Okay, so this is the point load, magnitude 50 at 1 meter, right? Exit. Assign the load. Now P2, say the magnitude is again 50 kilonewton and the distance is 2 meters, right, from initial point. Select the load, see the load. So this is your second load at a distance 2 meters, that is P2. Okay, exit. Now assign. Okay, now say this is the third point load, right? So again the magnitude is 50 kilonewton and the distance is 2.5 meters from the initial point. Press enter. Okay, select the member, see the load. Okay, so this is third point, right? Exit. Assign. Okay, say there is a fourth point load P6, which is at the magnitude is 50 and the distance is say 3, right? Again select the same member. You can see the point load. Okay, so this is how we give the point loads, right? Assign the value. Okay, now comes the axial forces. Now P3 is the axial load pointing toward IP. Okay, so let's take this load, say The magnitude is 50 kilonewton and it is acting at a distance 2 meters from the initial point, right? And say this is this member. We want to apply that axial force on this member. So this is your initial point. So that axial force pointing towards TP at a distance 2 meter will be seen. Okay, you can see the load. Right, this is your P3 pointing toward IP at a distance 2, right? Okay, let's assign the load. Now P4 is the another axial load pointing toward TP. Say the magnitude is 50 and the distance acting on the member is 2 meters from IP. And this is the member where we want to apply that load. Okay, so just select. You can see the loads. Okay, so this is our IP, this is our TP, this is pointing toward TP at a distance 2 meter from IP. Okay, now assign the load, right? Now you can also give a triangular load. Say magnitude is 75 kilonewton and the apex A is at a distance 1 meters from the IP. Say we want to apply this load over here. You can see the load, triangle load. This is apex A 1 meter from IP and this is the magnitude, right? So assign the value, right? You can see all the loads together also, right? These are the load we have applied. Okay, now as we have completed giving the loads, let's save the file. Let it be named as M. Okay, right? Now if you want to change some data, edit some, when I bring the pointer to a particular member, you can see the complete input over here. Okay, say this is for a member number 4, member number 6, member number 7, member number 14. Now suppose say you want to edit some data, then use this button. If you do you want to select member in serial, if you click yes, it will take all the members. No, we want to edit data in say member number 7. Just write 7 and press enter key. You can edit the data over here and then just come out by pressing enter key at each text box. Okay, resave the file after editing. Okay, now let us run analysis. Create input. Okay, the input is created. You can see the input, right? And now run analysis. Write the modulus of elasticity in kilonewton per meter square of the material. Say it is 2 exponential 8. Press enter key. Say the load factors are 1. Press enter. 1, press enter. Okay, click finish command. Okay, you can see the output. So this is the output of the frame. Okay, now you can see the sway. You can move the frame up down. You can zoom the frame as required. You can magnify the sway. You can see the bending moment diagram. You can see the shear force diagram. You can see the bending moment and shear force diagram for individual member. Say 14. I want to see it for the member number 14. Write 14 over here. Press enter key. Show shear force diagram. Show bending moment diagram. You can see the value of shear force and bending moment for any point on the member from the distance measured from the initial point. Say 1.5 2 meters. Press enter. So you get the shear force and bending moment. You can also scroll and get the shear force and bending moment at different distance from the initial point of the member. This J9 is initial point and this is your terminal point, right? Okay, after doing the analysis, you can go to program list, and on design form you can design the different elements of these frames. This will give the design for all the beams in that frame. F5 is 415, press enter. F6 is 20, press enter. Limiting depth of the beam is 450 mm, press enter. And condition is 3 as it is continuous or restrained. Okay, press enter. Okay, you can see the output. Okay, so this is how all the beams are designed. You can see, but over here the effective cover considered is 50 mm. Okay, so you can use this program where you can change the effective cover, which we'll see in design section. Okay, similarly you can design all the columns, okay, by this program. Right. So this will see in detail when we come to design. Okay, thank you.